Good morning, dear students. My name is Ferhan Mazher, and today is 26th of October 2021. And the day is Tuesday, and right now I am with the 11th Cambridge class, and the subject we are studying is Physics 5054. This is Cambridge O Levels Physics, and today we have set our hearts to solve May June 2006 paper 1. And this paper is basically from the zone 2. At that time there were no variants, so we can say this is from the variant 2. So let's start this paper, and this is an MCQ paper. This paper is based on MCQs. There are 40 MCQs. You have to attempt all of them, and the time allowed is 1 hour. So let's start this paper. There we go. That's MCQs. So we are going to attempt May, June 2006, paper 1, multiple choice questions. Okay. So question number 1 is coming up on your screen. And the question says, which graph shows the motion of a heavy steel ball falling from a height of 2 meters? So this is very important to note down that he's saying a heavy steel ball. So if you are talking about a heavy steel ball, you know that in the fall of 2 meters, it's falling from the height of 2 meters. Because it's heavy, so the air resistance which it will get during that 2 meter height, that will be not enough to overcome its weight and produce the terminal velocity, to achieve the terminal velocity. So its graph will be, speed time graph will be, is supposed to be uniformly increasing. The acceleration should be uniform, because the weight is large and the height during in which it is traveling is only 2 meters. So it will not be able to achieve the terminal velocity. So I think the graph should be something like this. These two are straightforward rejected because they are distance time graph. Okay, so speed time graph, and it should be an inclined straight line because the terminal velocity cannot be achieved, because the height is very this 2 meter height, just 2 meter height. In that height you cannot get to the terminal velocity because the steel ball is heavy. So I think question number 1 is the A is the answer. So let's check. So it's May June 2006 paper, question number 1, A is the choice. Okay, so let's go to the next question. Here we go. A force of 20 Newton pushes an object of mass 5 kg along a rough horizontal surface where the frictional force is 5 Newton. What is the acceleration of the object? We know the applied force, that's 20 Newton. And we know that the force is 20 Newton, and the friction is, the friction, that is 5 Newton. So the resultant force will be applied force minus the frictional force, and that will be 20 minus 5, that will be 15 Newton. So the resultant force will be 15 Newton. The mass is given, that's 5 kg. So I can find the acceleration by using the Newton's second law of motion, that is F equals to ma, and A will be equals to F by m. So very easily I can find my resultant. Okay, now you can see that Applied force is 20 Newton and the mass is 5 kg. The friction is 5 Newton. The resultant force will be 20 minus 5. That will be 15 Newton. F is equals to ma. So A will be equals to F divided by M. So 15 divided by 5. So that will be 3 meter per second square. So I can very easily find out the acceleration. So I think 3 Newton is the right answer. 3 Newton is the right answer. 3, sorry, I said 3 Newton. It's 3 meter per second square. C is the choice. Question number 2, C is the choice. Let's check the marking scheme. Question number 2, C is the right choice, sir. Okay. So the next question coming up on your screen, the diagram shows a Vernier scale. What's the reading on the Vernier scale? So this is how you take the reading. This is the zero of the Vernier, and this is the main scale. First of all, we check the zero of the Vernier has crossed how much on the main scale. So if this is 6, this is 7, 6.1, 6.2, 6.3, 6.4, 6.5, 6.6. So this zero has crossed 6.5. So you will note down 6.5. Okay. So you will note down 6.5. And then I will check which line coincides of the Vernier scale, which line coincides with any line of the main scale. So 1, 2, 3, 4, and this 5th line. So at the end, I will write again 5. So the reading is 6.5 and centimeter. So this is the reading. So clearly, I think the B is the choice. Question number 3, B is the choice. So let's check. Yeah, question number 3, B is the right choice, sir. Okay, so question number 4 is coming up on your screen. And the forces X and Y act on a block in the direction shown on the scale diagram. In which direction is the resultant force acting? Okay, so here I have a force Y and here I have a force X. And you know that when these are the two vectors and I want their resultant, because you have put these vectors in such a way that their tails are joined. Here their tails are joined. And if you want to find the resultant, we use parallelogram. If you put two vectors to be added in such a way that their tails are joined, then we use the parallelogram law. So in the parallelogram law, what I will do, I will suppose that these are the adjacent sides of a parallelogram, and I will complete that parallelogram. And then once the parallelogram is completed, then I will join the point where the tails are joined. I will join it with the opposite corner of the parallelogram, and that will be the resultant. So here we have 4 options. Let me show you on my work. Okay. So here you can see, you can see that I have that these are the two vectors to be added. So parallel to this, I draw a line here. Parallel to this, I drawn a line here. So the parallelogram is completed. Then I join this point where the tails are joined with the opposite corner. So this blue color line is my resultant. So hopefully this B is the right answer, sir. You can do that same thing if you have the hard copy of this paper. You can do this on this diagram. You see, parallel to this, draw a line here, and parallel to this line, draw a line here. And when you will do this, you will find that B is actually the result. So when you use parallelogram law to add two vectors, the resultant is you join the points where the tails are joined. You join that point with the opposite corner, and that gives you the resultant. So I think B is the choice. So let's check. Where's the paper? So I think B is the choice. We think B is the choice, sir. So question number 4, B is the right choice. Okay, so let's move to the next question. And the next question coming up on your screen is question number 5. The question number 5 says that the diagram shows an aeroplane turning in a horizontal circle at constant speed. In which direction is there a resultant force? So because the aeroplane is turning in a circular circle, so whenever anybody moves in a circle, the direction of the resultant force is always towards the center of that circle. So I think if this is turning like this, so as the plane is turning in this circle, so its center will be at D. So D is the right direction in which the resultant force should be directed, because when you move in a circle, the resultant force is always directed towards the center of the circle. And D looks the right option, sir. So question number 5, D is the right option. So let's check. Question number 5, D is the right option, sir. Okay, so next question. The inertia of a body is its resistance to changes in motion. Which property is a measure of the body's inertia? The inertia is basically depends upon the mass of the body. So it will be mass. Which property is a measure of the body's inertia? That is mass. So I think B will be the right answer, sir. B, question number 6, B part. Let's check. Question number 6, B is the right answer. Okay. Question number 7 is on your screen. An object of mass 100 gram is immersed in water as shown in the diagram. So here we have a measuring cylinder, and in that measuring cylinder, we have filled it with the water. And the volume, we call it V1, is right now 50 centimeter cube. And when I immersed that object into the water, the volume of the water appears to be 90. So let me call it V2. When V2 minus V1, it will be 90 minus 50. That will be 40 centimeter cube. So that 40 centimeter cube will be the volume of this object. So I know the mass of this object, that is 100 gram. I know the volume of this object, that is 40 centimeter cube. So very easily I can find the density of this object. You know, the density formula is mass divided by volume. So let me show you my work. I have also done this on a paper. So the mass is 100 gram and the volume V is equals to V2 minus V1. That will be 90 minus 50. And that will be equals to 40 centimeter cube. The density is the question. You know the density is equals to mass divided by volume. Mass is 100 gram. The volume is 40 centimeter cube. So 100 divided by 40 will be 2.5 grams per centimeter cube. So I think the density will be 2.5 grams per centimeter cube. So let's check the options. So it will be something like 2.5 grams per centimeter cube. So for question number 7, I think D is the right answer. Let's check. Question number 7, D is the right answer, sir. Okay. So then we have the question number is if a nut and bolt are difficult to undo, it may be either to turn the nut by using a longer spanner. It may be easier to turn the nut by using a longer spanner. This is because the longer spanner gives. You see, if you use longer spanner, the longer spanner actually increases the moment arm. So, the moment is equals to the force multiply with the moment arm. And if the moment arm will be longer, larger, the turning effect will be also larger, or the moment will be larger. So this is because the longer spanner gives a larger turning moment. Yes, that's true. A smaller turning moment, that's wrong. Less friction, that's wrong. More friction, that's wrong. So the best option is, because when you use a longer moment arm, so the same force will produce a larger turning effect. So question number 8, A part. So let's check. Question number 8, A is the right answer, sir. Some containers are made from thin glass. Which empty container is more stable? More stable will be that whose most mass is lower, means in lower portion, and whose base area is larger, and the mass in the upper area is less. So clearly it's A choice, because its base is quite wide and most of the mass will be here. So its center of gravity and center of mass, they will be lower, so it will be most stable. The lowest the center of gravity, the more stable that object will be. So this looks more stable because at the bottom its base area is larger, and at the bottom the mass is more, and as you move up it becomes the flask becomes thinner and thinner, so it's no more wide. So its most mass will be lower here somewhere. So it will be more stable because its center of mass, center of gravity will be lower. So question number 9, I think A is the right answer. So let's check. Yeah. Then we have question number 10. A metal wire initially 1 meter long extends by 4 millimeter when a load of 2 Newton is added to it. What will the length of the wire be if a further 3 Newton is added, assuming it does not extend beyond its limit of proportionality? Now, he says when there is no load, the length is 1 meter. And when you put 2 Newton load, the extension is 4 millimeter. So when you put further 3 Newton, it means that the total load will become 5 Newton. So we have to find what will be the length. Okay. So first of all, I will find out what will be the extension, and then I will add that extension into the unstretched length, which is 1 meter. So let me show you how we do this. I've done this on a paper. Okay, so here we go. So the L naught is 1 meter. L naught means unstretched length, or when there is no load, the length, that is L naught. That's 1 meter. He says load and extension. He says when I put 2 Newton load, the 4 millimeter extension is produced. So when you put further 3 Newton on it, so the total load will become 5 Newton. So what will be the extension? So I can write this in the fraction. So that will be 2 by 5 equals to 4 by x. So 2x will be equals to 20, and x will be equals to 20 divided by 2, and that will be 10 millimeter. So the units they're using is millimeter. So there will be an extension of 10 millimeters. So, okay, so the length is L naught plus the extension. The L naught is 1 meter. and the extension is 10 millimeter. So I will convert it into meters. So that will be 10 divided by 1,000, and you will have 10 divided by 1,000. That will be 0.01 meter. So 1 meter plus 0.01 meter will be 1.010 meter. So the new length will be 1.010 meter. So let's check. So let's check the answer. 1.010 meters. So I think C is the right choice. Question number 10. So let's check. Question number 10, C is the right choice. In a hydroelectric power station, water from a reservoir falls down a long pipe before entering the turbines. The turbines then run the generator. What is the overall energy conversion? Okay, so electric energy into kinetic energy, no. Electric energy into potential energy, that's wrong. Kinetic energy into chemical energy, that is also wrong. Potential energy into electric energy. So when the water falls, it has potential energy, and it falls on the turbines of the turbine blades. And what happened? Those turbines, they rotate. Their blades basically rotate, and that turns the generators. And this is how we produce the electricity. So the initial energy is the gravitational potential energy, and the final form of the energy which is useful to us is electric energy. So I think D is the right choice. I think question number 11. D is the right choice, and let me check that. 11, D is the right choice. So question number 11, D is the right choice. Okay. So question number 12 is showing up on your screen. He says, which statement about fission or fusion is correct? You see, in fusion, smaller nucleus, they come close to each other and they fuse into one another, and they make a very large nucleus. For example, two hydrogen atoms, they come close to each other, and the nucleus, they fuse into one another and they make helium. So smaller nuclei combine to make a larger nucleus, that is called fusion. Whereas in the fission, actually what we do, we take an atom and we bombard its nucleus with the neutrons, and that nucleus break and daughter nuclei are formed. So from a larger nucleus, we make smaller nuclei, and that is called the fission. So which statement about fission or fusion is correct? During fission, hydrogen converts into helium and releases energy. That's wrong. The process which is happening on the sun and on the other stars, where the smaller nuclei of the hydrogen, they come close and fuse into each other, and they make helium, and with this, lot of energy is given out, enormous amount of energy is given out. So that phenomena is called fusion. So A is not the answer. B, during fission, uranium converts into daughter products and release energy. That is true. We take a nucleus of uranium and we bombard it with a neutron, and that uranium nucleus breaks. So that happens in fission. So B can be the answer. During fusion, helium converts into hydrogen and release energy. That is wrong. During the fusion, hydrogen converts, they join together, they make helium. So C is not the answer. And D is during fusion, uranium converts into daughter products and release energy. So the fusion process is not happening in your, in your nuclear reactors. In our nuclear reactors, fission is happening. So during fission, uranium converts into daughter products and release energy. So this is the basic answer. And this is B answer. So question number 12, and it is B answer. So let me show you. Question number 12, B is the right answer. So we have question number 13 on your screen. The input power of a motor is 300 watt. 300 watt. In 20 seconds, it lifts a load of 400 Newton through a height of 6 meters. What is the efficiency of the motor? I know the input power. I can find out the output power, and then I can find the efficiency. Very simple. So let me show you. The input power is 300 watts. The time is 20 seconds. The load which we are lifting is 400 Newton. And the height to which it went is 6 meters. So the input power is, I wrote here input power. This word is basically output power. Let me write it. Okay, this word is supposed to be what? It is supposed to be, okay, this word is basically output power, okay, not input power. So here, this word is output power is equals to load multiply height and divided by time. So the load is 400 Newton, and the weight, the height is 6 meters, and that machine took 20 seconds. So the power will be, the output power will be 400 into 6 and divided by 20, and that will be 120 watts. So the output power is 120 watts. The input power to the machine is 300 watts. So I can find the efficiency. The efficiency is output power divided by input power multiply 100. The output power is 120 watt. The input power is 300 watts. So you multiply it with the 100 and you get 40%. So the efficiency of the system will be 40%. So okay, 40%. I think question number 13, C is the right choice, 40%. I hope you understand, and let's check the marking scheme. Question number 13, C is the right choice. So we can check. Question number 13, C is the right choice. So let's check. Yeah. So question number 14, the diagram shows to the same scale the vertical section of a set of circular vessels. Each vessel contains the same depth of the water. Which of the following statement is correct? If all these, you can say, vessels, the vertical height of the liquid is same in all of them. If the vertical height is same, then the the pressure will be same. The pressure is rho GH. The pressure is rho GH. If their G is same, if their rho means density is same. So, so if they all have the same vertical height, so the pressure at the bottom of all of them will be same. So what's the option? The water exerts the greatest pressure on the base of the vessel P. That's wrong. The water exerts the greatest pressure on the vessel, the base of the vessel S. That is wrong. The water exerts the same force on the base of each vessel, and the water exerts the same pressure on the base of each vessel. That is right. So the water exerts the same pressure on the base of each vessel. So D is the right option. So we have question number 15 coming up on your screen. He says some of the more energetic molecules in a liquid leave the surface, leaving the rest of the liquid slightly cooler. What is the name given to this process? This is the evaporation process. This is the evaporation process. The question number 15, C is the choice. Let's check the marking scheme. C is the right choice, sir. A substance consists of particles that are close together and move past each other at random. The average speed of the particle is gradually increasing. So if the average speed is increasing, it means that the kinetic energy is gradually increasing. So what best describes the substance? A gas being heated. A substance consists of particles that are close together and moving past each other at room temperature. So it's a solid basically. A liquid being heated, no. A solid being heated, yes. A solid being melted, no. So I think a solid being heated. The next question is, which thermometer is the best for measuring the rapidly changing temperatures? If you want to measure the rapidly changing temperatures, the best thermometer will be thermocouple. A thermocouple. I think C is the right choice, sir. Let's check. C is the right choice. Some ice cubes are taken from a deep freezer and placed in a metal container. The container is heated at a constant rate and the readings of the temperature and the time are taken. The results are which temperature corresponds to 0 degree. You see, it was frozen and they increase its temperature. Obviously, when this becomes flat, that shows that the state is changing. Okay, so 0 degree will be at the point C. The diagram shows a bimetallic strip when it is at room temperature and after it has been cooled. The change in the shape occurs because, you see, this is at normal temperature and this white portion is showing brass and this gray portion is showing amber. So when you cooled it, it bended upward. So it bended upward. The reason, try to understand the reason, is the bending upward shows that the brass is contracting more and the amber is contracting less as compared to the brass. So that's why it bended upward. You see, when you cooled it, both the brass and the amber, they will try to contract. So because the brass has contracted more, that's why it has bended upward, and in that curve, the brass has become the inner portion of that curve. So that shows that the brass has contracted more as compared to the amber. So the brass contracts more than the amber. That is the right answer, sir. We can read the next other options also, but the right answer is here, just in front of us. The brass expands when it cools down. That's wrong. Amber and the brass contract by equal amounts. That is wrong. Amber contracts more than brass. That is also wrong. So because it has bended upward, so the brass has become the on that side. Because it has curved upward, so the brass has become the inner portion of that curve. So that shows that the brass is contracting more as compared to amber. So that's A choice, question number 19. A choice, let's check. Question number 19, A is the right choice, sir. The density changes are responsible for which method of thermal energy transfer? You see, the density changes are responsible for the convections only. So I think B is the right choice. We have to check. Question number 20, B is the right choice. Yeah, B is the right choice. B is the right choice. Okay, question number 21. There we go. In an experiment using a ripple tank, plane wavefronts arrive at a plane surface. So here we have the wavefronts. They are water waves. They are coming, and here we have a plane surface. So they will collide with this surface, and they will be reflected. Which of the following correctly describes the waves after they are reflected from the surface? The speed of the waves. The speed of the waves will not change. It will remain the same. And the wavelength, that will also not change. It will remain because it's reflection. So when the water waves are reflected, their speed do not change, their wavefronts do not change, their wavelengths do not change. So I think D is the right option, sir. Here it says that the wavelength, speed of the wave remains the same, the wavelength remains the same. So I think question number 21, D is the right choice. So let's check. Let's check the marking scheme. Yeah, D is the right choice. Waves pass from deep water to shallow water and refraction occurs. So here the waves are entering from deep water into the shallow water, and you can see the speed of the wave in the deep water is 2 meters per second. The wavelength of the wave in the deep water is 1 meter. So here I know the speed, I know the wavelength, lambda. So I can find out the frequency of the wave here. So V is equals to F lambda. So the F will be equals to V by lambda. So that will be 2 meter per second divided by 1 meter, and that will give you 2 hertz. So whatever is the frequency of these waves in this deep water, same will be the frequency of these waves in the shallow water. But in the shallow water, if the frequency is still the 2 hertz and the wavelength has become 0.4 meter in the shallow water. So you see, I can find out the speed. The speed is V equals to F lambda. So if the F is 2 hertz and the lambda is 0.4 meter, so when you multiply them, you get 0.8 meter per second. So I think B is the choice. Let me show you my answer also. I have done this on a paper. So in the deep water, the wavelength is 1 meter, the velocity is 2 meter per second. Sorry, F is question mark, V is equals to F lambda. F will be equals to V by lambda. So F will be equals to 2 by 1, and that will be 2 hertz. So when the same wave will go into the shallow water, you know, the frequency do not change. The frequency remains the same. So the frequency will be 2 hertz. The wavelength is 0.4 meters. 0.4 meters is coming from that diagram in the question. And their question is, what is the velocity? So you know V is equals to F lambda. So F is 2 and the lambda is 0.4. So the answer will be 0.8 meter per second. 0.8 meter per second. So let's check. 0.8 per second. 0.8 meter per second. So let's check question number 22. B is the choice. Yeah, B is the right choice. A lens forms a blurred image of an object on a screen. So here you have a lens. It's a convex lens, and it's bending the light rays. It's converging the light rays. And we have put a screen there, and you can see that the lights, the rays, they are not crossing each other on the screen. Rather, they are crossing each other before the screen. So the image will be blurred. Okay. So how you can focus this image onto the screen? You can move the screen towards the lens. Bring the screen here, and you will find a sharp and clear image. Or you can use, you put a lens here who has larger focal length. So by moving the object away from the lens and the screen, that's wrong. By moving the screen away from the lens and the object, that's wrong. By using a brighter object at the same position, that is also wrong. By using a lens of longer focal length at the same position. So here you put a lens whose focal length is longer. So instead of crossing here, they will cross on the screen. So I think D is the right choice. Light rays are deviated by a prism. The deviation angle D is measured for light rays of different frequency, including the blue light and the red light. Which graph is correct? Okay. So you can see that on the x-axis, the frequency is shown, and on the y-axis, the angle of deviation is shown, this angle. So the blue color will have higher frequency, and its angle of deviation should also be larger than the red color. So blue should be has higher frequency on the frequency axis. It should be here, and the blue's angle of deviation should also be larger. So I think D is the right choice. It's a little brand new question and it's tricky. It's not brand new because it was published in 2006, but it's a good question. So the question number 24, we think D is the right choice. Yeah. Okay. Which wave is part of the electromagnetic spectrum? You know, electromagnetic spectrum, the waves are transverse waves. In the electromagnetic spectrum, the waves are transverse wave, and they travel with the speed of light. And you know, the speed of light is 3 × 8 m/s. So I think D is the right choice. So D is the right choice. D is the right choice. Question number 25, D is the right choice. Yeah, D is the right. A boy strikes a rigid metal fence with a stick to create a sound along the fence. A girl listens with her ear against the fence. 1 second after the fence is struck, the girl hears a sound through the air. How long will it take for the sound to reach the girl through the fence? You know, the speed of the sound in the metallic fence will be larger than the speed of the sound in the air. So the sound will reach the girl before the sound will reach the girl through the air. So the sound will reach the girl through the fence earlier than the sound will reach the girl through the air. Through the air, the sound took 1 second. So through the fence, it will take less than 1 second. So I think B is the right choice. So do we think B, 26B is the right answer? Yeah, it's right. The diagram shows an iron nail in 4 different situations. The diagram shows an iron nail in 4 different situations. In which diagram will the nail become an induced magnet? You see, to make it induced magnet, we have to close this switch. Here again, we have not closed the switch. This is just iron bar, so if you put a nail beside it, nothing will happen to the nail. And in the part A, you have put the nail beside a magnet. So when you put beside a magnet, this nail will also north and south will be induced on it, and it will also start behaving like a magnet. So in question number 27, I think A is the right choice. If you put the nail with another nail, I'm sorry, if you put the nail with another magnet, the nail will be magnetized, and north and south will be induced on that nail. Okay. So question number 27, A is the right choice. So let's check. Question number 27, A is the right choice. The diagram shows parts of a loudspeaker. So here we have that paper cone, and here we have that permanent magnet. Here under that paper cone, we have put a coil. So this is that coil which we have in the speakers. And when the current flows through them, they are sometimes attracted, sometimes they are repelled. So this paper cone, due to the attraction between that conductor wire and the permanent magnet, this cone will move up and down, up and down, up and down. It says which type of current is passed through the coil and why. The current which we supply to the speaker is the alternating current. So sometimes it pushes the cone outward, and sometimes the cone is pushed backward. So the which type of current is passed through the coil and why we provide with the alternating current. Why you provide it with the alternating current? Because due to the alternating current, this paper cone will move up and down. It will vibrate. Actually, you know what happens? The reason why we have to provide the alternating current, he says, to keep the magnetic field constant to make the coil vibrate. We provide the alternating current in that coil so that to make the coil vibrate. So when sometimes it's attracted, sometimes it's repelled. So that's why the cone will move up and down. So I think question number 28, B is the right choice. So let's check. Question number 28, B is the right choice. In an electrostatics experiment, a plastic rod is rubbed with a cloth. The cloth becomes negatively charged. Which diagram shows the charge on the rod? You see, when you rub the rod with the cloth and the cloth becomes negative, the rod will become positive. If the cloth will become negative, the rod will become opposite of it. It will become positive. Okay. So where the rod has become positive. Yeah. So he says electrons move from the rod onto the cloth. That is true. So A can be the answer, sir. You see why I'm taking A as the answer, because when you rub the cloth with the rod, the cloth becomes negative. If the cloth has become negative and the rod has become positive, so it means that the electrons from the rod has gone into the cloth. That's why the cloth is negative. So that is question number 29. A is the choice. So let's check. Question number 29, A is the right choice, sir. An electric quantity is defined as the energy converted by a source in driving a unit charge around a complete circle. That's the definition of the EMF. Remember this definition. Electric quantity is defined as the energy converted by a source in driving a unit charge round a complete circuit. That is called the electromotive force, EMF. So I think clearly B is the choice. So we will have to check. Question number 30. B is the right choice. The diagram shows the current I, voltage V graph for a length of resistance wire. So where can Ohm's law be applied to the wire? You know, Ohm's law means that the I and the V, they are directly proportional to each other. So I and V will be directly proportional to each other until that point where the graph has a constant gradient. Once the graph's gradient starts changing, so we say the Ohm's law is not obeyed. So Ohm's law is obeyed from O to Y because the graph is a straight line graph between I and V. So at Y only, at Z only, where can Ohm's law be applied to the wire? At Y, at Z only, from X to Y. That is the answer. So I think C is the choice. That let's check. Question number 31, C is the right choice. Okay. So question number 32 is showing up on your screen. He says the diagram 1 shows a resistor connected to a battery, an ammeter and a voltmeter. The ammeter reading is 0.5 ampere. So there the reading is 0.5 ampere. And this is showing 3 volt. So I can find the resistance of this, resistor. So V is equals to IR, B equals to IR. So I know the voltage drop, that is 3 volt. I know the current, that's 0.5 ampere. So I can find the resistance in the diagram number 1 of the resistor. So once you know the resistance, and then he takes two identical resistors, connected them in parallel, and same battery. So if the same battery here, all the voltage, all the EMF was being used, and that was 3 volt. So here they combine the total voltage here will be equal to the voltage of the battery EMF, and that will be still 3 volt. And because these two are connected in parallel to each other, so I can find their resistance, combined resistance. So let me show you. Question number 22 is done. Okay, so diagram 1, in the diagram 1, V is equals to IR. So R is equals to V by I, and that will be 3 divided by 0.5, and that will be 6 ohm. So the resistance is 6 ohm. In the diagram 2, those two resistors, they are connected in parallel to each other. So I can find their equivalent or combined resistance. So 1 by R equivalent is equals to 1 by 6 plus 1 by 6. So 1 by R equivalent is equals to 2 by 6. So that R equivalent will be equals to 6 by 2, and that will be 3 ohm. So the resistance in the second diagram will be 3 ohm. So according to the formula, V is equals to IR. So V value is still 3 volt. R value is also 3. So I is the question. So I will be equals to 3 divided by 3, and that will be 1 ampere. So the reading on the, that, yeah, so reading on the ammeter will be 1 ampere, and the voltmeter will show 3 volt. So I think A is the right choice. How much energy is converted in a resistor of 5 ohm carrying a current of 2 ampere for 10 seconds? So we want to calculate the electric energy. The formula for the electric energy is very simple. Let me show you how I have done this. I have done this on a paper. Okay, so R is 5 ohm, I is equals to 2 ampere, and T is equals to 10 second. You know the energy is equals to IVT. So in the place of V, I can put IR, Ohm's law, I into IRT. So the formula will become I square RT. So the I value is 2, so it's square into 5 and into 10. So it will be 4 into 5, that will be 40, 20 multiplied, and that's 200 joules. So the answer is 200 joules. Question number 33. 30, question number 33, 200 joules. So D is the option. D is the right option, sir. So let's check. D is the right answer. And for 32A is the answer. Let's check which answer I have taken. Yeah, 32, question number 32A is the right choice. Two parallel wires carries current in the same direction. Which diagram shows the magnetic field around each wire and the direction of the force on each wire? You know, both these conductors, the current has in the same direction. So when the current is in the same direction, they will attract each other. When you have two conductors which are in the two conductors, you know, I mean, they are parallel to each other and the direction of the current is same. So they will attract each other. So you know, A is showing attraction, the B is showing attraction, so they can be the answers. C and D cannot be the answers because they are showing repulsion. So C and D is out of question. Now A and B. Now I can check the magnetic field by using the right hand rule, you know, according to the right hand rule. According to the right hand rule, hold this conductor in your right hand in such a way your thumb is pointing in the direction of the conventional current. Then the curls of your right hand, they are basically showing the direction of the magnetic field. So the direction of the magnetic field in the see, I am checking it in the A figure. The thumb is pointing downward. My curls are telling me that the direction of the magnetic field will be, you know, clockwise. So in both of them, it should be clockwise. So B cannot be the answer here. The direction of the magnetic field is anti-clockwise, so it's rejected. So A is the right answer. So you know when you have two straight conductors and those two straight conductors, those two straight conductors basically they have current in the same direction. So if the current is in the same direction, they will have attraction with each other. So A is the choice. Question number 34. Question 34, A is the right choice. A permanent magnet moving up and down on the end of a spring induces an EMF in a coil. So you see here we have a coil, here we have a magnet attached with the spring. When you will stretch it a little and then you release it, what will happen? This magnet will move up and down, because it was connected with a spring. So when this magnet will move up and down, so in this coil, the EMF will be induced. And why the EMF will be induced? Because when this magnet will move up and down, so you see the magnetic lines coming out of this magnet, they will pass through this coil. So when the magnetic lines will pass through this coil will also become magnet. It will start behaving like a magnet. Which factors on its own would decrease the maximum value of the induced EMF? Increasing the number of turns in the coil, no, that increases actually. We are looking for that factor would decrease the maximum value of the induced EMF. Increasing the strength of the magnet, no. Raising the coil, yes, that can be. And raising the support, rising the support of the spring. Raising the support of the spring. Okay. So if you raise it, so no. So their question is, which factor on its own would decrease the maximum value of the EMF induced? Increase the number of turns in the coil, that will increase, actually not decrease. Increase the strength of the magnet, that will also increase. Raising the coil, that will not increase, that will increase again. Raising the support of the spring, yes. If you take the spring away little higher, then the magnetic lines which will be reaching the coil, they become less. So smaller and less in the EMF will be induced. So I think D is the right answer. It's not a straightforward question, okay? 35D is the right answer. So let's check. 35D is the right answer. Why is a transformer used to connect a generator in a power station to a long distance transmission line? The question is, why is a transformer used to connect a generator in a power station to a long distance transmission line? You see, we put a transformer there to step up the voltage. So when you step up the voltage, the current decreases. When the current decreases, the power loss in the transmission lines will decrease. So he says to decrease the voltage and decrease the current, no. To decrease the voltage and increase the current, no. To increase the voltage and decrease the current, yes. This is the purpose of that step-up transformer. It increases the voltage and decreases the current. So basically, C is the choice. Okay, question number 36, C is the choice. So let me check. Question number 36, C is the right choice. He says the table shows part of the color code for resistors, and which resistor has a value of 4700 ohm. Okay. Now, you know how we find the color bands. This first digit is 4. So that will be yellow. The first band should be yellow. The second figure is 7. So it should be violet. The second band should be violet, yellow and violet. So A and B, they are competing with each other. And then these two means 100. 100 means 10 raised to power 2. So 10 raised to power 2. So 2 is the basic thing. So the red color. So you will have yellow, violet, red. That will be the A part. Now listen carefully. I will explain this question. I have done this also. So you can see the first digit, second digit, they will be represented with the color. So 4 is represented with the yellow color, and the 7 is represented with the violet color. The last is basically 47 into 100. So 100 means 10 raised to power 2. So I will look for this 2 color. So 4 is yellow, 7 is violet, and this 2, which is 10 raised to power, and that will be red. So A is the right choice. Question number 37. A is the right choice. Yes. A student investigates the emission from an unknown radioactive source. The source is 10 centimeter in front of a detector. A strong magnetic field between the source and the detector is then switched on. Okay, so a strong magnetic field is here. Okay. So here we have a radioactive source and we have a lead shield. And here you have the region of the magnetic field. Here we have a detector. So the results are shown without magnetic average count per minute. So average count per minute without the magnetic field is 4,500. So most of the alpha particle, so most of the radiation is passing, and it's able to reach here, the detector, I mean. Then we have the magnetic field. So when you switch on the magnetic field, the radiation which is reaching the detector is now only 2000. It means 2500 so when you apply the magnetic field here, so the total radiation which was reaching the detector was 4500. So when you switch on this magnetic field, only 2000 was able to reach the detector. The rest has deflected, which shows that they have charge on them. Okay. So which radioactive source produced these results? Emission from the source, alpha particles and gamma rays only. So there are, I think, alpha particles because they have been deflected in the magnetic field. And there are some gamma rays also because they are not affected by the magnetic field. A very tricky question, okay? So A is the right choice, sir. I think A is the right choice. Let me check. Beta particles only cannot be the answer, because if there is beta particle only, so they will be deflected when there will be magnetic field, and there should no radiation reaching the detector. But the detector still showing 2000 reading, which means some radiation is still coming, reaching the detector. C is beta particles and gamma rays only. He says beta particle and gamma rays only. And D is gamma rays only. That cannot be possible. D cannot be possible. Okay. So beta particles and the gamma rays only. So you see, this also has the same kind of answer. Let me read the statement. Now we have a competition. Both these statements looks right. But this detector is 10 centimeters from this source. See, it's very important. The source and the detector, they are 10 centimeters apart. So the radiation which is coming out of here and reaching the detector cannot be alpha particles, because their penetrating power is very low. So they cannot travel 10 centimeters in air. So alpha particles cannot be the answer. So the right answer is, sir, C, beta particles and gamma rays only. So we think that the question number, let me reduce the size so you can see the whole question. So question number 38, I think C is the right choice. You see, at the end, there were two statements, and then how we rejected the A part. Because if alpha particles cannot travel 10 centimeters in air. So C is the right choice for question number 38. Let's check. Question number 38, C is the right answer, sir. Okay, so the next question coming up on your screen is question number 39. He says a detector is used to measure the count rate near a radioactive source. The reading is 4,000 counts per minute. After 30 minutes, the count rate has fallen to 500 counts per minute. What is the half-life of the radioactive source? You may ignore the effect of the background radiation. Okay, so let me show you how I have done this. Okay, now at the start, the count rate was 4,000. When one half-life will pass, it will become 2,000. When another half-life will pass, it will further half. So now you will have 1,000, and when another half-life will pass, you will have 500. So how many half-lives have passed? 1, 2, 3. 3 half-lives. So 3 half-lives is equals to, he said 30 minutes have passed. So it means 3 half-lives equals to 30 minutes. So 1 half-life will be equals to 30 divided by 3, and that will be equals to 10 minutes. So it means that the half-life is 10 minutes. So the half-life is 10 minutes. So D will be the right answer. So I think D is the right answer. So let's check question number 39. D is the right answer, sir. Yeah, 39 is D. Now, question 40 is showing up on your screen. He says, which conclusion can be drawn from the Geiger-Marchson alpha particle scattering experiment? You see what they did? They took a gold foil, a very thin gold foil, and they bombarded it with the alpha particles. And they put a photographic film around it. And what they observed, that most of the alpha particles went straight, like there's nothing in their path. And very few of the alpha particles were deflected at larger angle. So from there, they concluded that every atom has a nucleus. Most of the space in the atom is empty. The mass of the atom is concentrated in a small nucleus. So which conclusion can be drawn from the Geiger-Marchson alpha particle scattering experiment? A positive charge is spread throughout the atom? No. Electrons are arranged in orbits. Electrons are negatively charged. Yeah. There is a dense nucleus in the atom. Yes, the nucleus is very dense. All the mass of the atom is inside the nucleus. So there is a dense nucleus in the atom. So I think D is the right option, sir. This question is very tricky. Okay. So my dear students, by doing this paper, we have reached the end of 2016. We have reached the end of the 2016 paper. Sorry, 2006 paper. This is May, June 2006 paper. We have done this paper in this session. So hopefully you will be able to understand this paper. If you find this paper interesting or you find this video helpful in solving the physics paper, don't forget to subscribe to my YouTube channel and don't forget to like this video. And if you find this video helpful to you, share the link of this video with your friends and with your class fellows. And that will be a great appreciation for me. So everybody, thank you very much and have a good day, and God bless you all.